here on my talk, Beauty and the Beast, Haskell on the JVM. So, like, I will first, okay, this is a talk about something called Eta, and that's the logo, something you should like remember after the talk. This is the logo of very awesome thing. And about me, Jarek Ratajski. I am an architect at Ingenious GmbH. If you wonder what's an architect, is the one that brings chaos to the projects, because a lot of the teams suffer because they have too many architects that enforce so much order that it's hard to do anything at the end. So I am breaking that stuff and breaking architects, and I am an architect. And of course, we hire for fun projects in Switzerland, Zurich. Talk to me if you want, if you are good. And think I am a Java developer, but with a little bit functional heart. So I even did, like in 90s, a little bit of XML, of course, only for academic purposes. Then a little bit of Haskell. I love those languages, but I always thought it's something that will never be used on production. Right? Okay, but now there are a lot of people that have the same problem. They like functional languages, functional programming, and the real functional programming, so like pure functional programming, and they do Haskell. That's why one of the most loved language, Haskell. And the thing is that when they do something in Haskell, finally comes industry production, and the problem is that they are facing the wall, like, oh, sorry, is it running on JVM, on Tomcat or WebSphere? Oh, that's a problem. So what are the solutions for that? Because that was partially my problem. I'm not that big fan of Haskell. I do it not really professionally, not full time, but I like functional programming. So what's the answer? That's actually my code, and people call it writing Haskell with Java. So you see a lot of flat maps. It doesn't really look very nice, especially that finally sometimes you have to mix it with Java exception handling, which doesn't fit to functional world at all. So yeah, that's one of the solutions that works but doesn't look good. So the second solution is like, and more people do that. They write Haskell using Scala, and even in Scala there are libraries that let them feel almost like in Haskell, so especially Scala Z. Funny, because I was trying to find a quite radical piece of code that does this approach, so it's like Haskell transpiled to Scala. I put it randomly, forgetting who has written that, and recently author contacted me. Oh, that's my code you put on your presentation. It's from the GitHub, but still funny that this world is small. And so the solution might be like, why not write Haskell using Haskell? That's so crazy. And then maybe deploy it to JVM. Why not? Because JVM potentially can run anything. So why not the Haskell? And even glue with some Java libraries that are established. That would be awesome. And exactly for that reason, there is a company, Typelit, founded, and they try to provide Eta as Haskell that runs on a JVM. So Haskell to bytecode compiler simply. And I will be today talking more or less how it works. It will not be a less detailed lesson what a Haskell is. I will show some code, but more about the approach and what kind of problems or interesting things you will find. So one thing, I'm absolutely not associated with Typelit, and what I say here is just, sorry, that's disclaimer I have to say, because I don't want to harm the company at all, and I might be wrong, because this is research I did on my own in my free time. I'm not doing it full time. I contacted people from Typelit, the community. They are very helpful. I will be addressing that later. But still, I'm not a professionalist at it. So could be if something that I present today is important for your business, better recheck on your own. Okay. So, and what I'm talking is like, Eta is not yet finally productive ready, at least from the production ready from the version number. It's like 07 something. So However, let's talk about it. So what it is, maybe I will try to do some coding for you to show you a Haskell that works. I'm really bad at coding if I don't have my wizard rope, but I will try to do it today. So this is the Haskell main, and as every good program, also Haskell programs start with main method, and I can start with something that will not make me a problem. I will write hello GeeCON, okay, and then I can compile it. I can compile it using the command that's called Eta. That's installed compiler. So I do Eta. And this particular code is called quicksort A because I'm going to present you something that is almost a quicksort, and to have to present how funny the Eta is. Okay, so I'm compiling that, and you see that it's linking to jar. So it's like I am compiling Haskell code, which is this one. It takes a while because the jar that it produces is pretty big. But we can run it, so run it this way. It's normal Java jar run command. Let's do it. And we have hello GeeCON. Okay, but I was here to present you a quicksort, so we'll do something like I will present you some table of numbers like 3, 5, 7. Oh, it's already sorted, but I will make it harder, like -5, 42, and 33. Okay, and maybe again I will compile it. Oh, there is already an error because I haven't written something like this. Show, probably. So show is basically like convert the something into the string. So you might wonder, well, who knows what this dollar means? Okay, it's like you will get a lot of money if you learn Haskell. But there is really one of the things in a language that's very specific to Haskell, and basically it means that everything after dollar is in braces. So like, please evaluate everything here first, and then use the result of that for put string ln. Okay, but it's like I make it smaller. Just okay. So maybe it would be good to really write something that is a quicksort. So I will define the quicksort, and in Haskell we can do it this way: quicksort from maybe the first the simple case from empty list. I would write it. This is an empty list, and like this should work on an empty list. That's for me quite okay. Maybe I can even use it here. Show, and let's compile it and see what's happened. Oh, quicksort is not there. I must have made quicksort. Okay, there's as you see the compilation errors are quite okay. The problem is that it already says it won't compile because my quicksort definition, it only works for empty list, is not sufficient. So I have to like make it more precise what to do in case of bigger list. Of course it would work on empty list, but I just won't waste your time presenting that. So maybe if I have a list of one element, what is a quicksort of one element? It's of course very simple. It's just this one element, just this. And again, I can try to compile it, probably without. Oh, something is trying to work. We'll see what happens. That's interesting, in fact. And we'll run it, and we'll see what happens. We should see some. Whoa, it didn't work. So this time you've seen that Haskell is not that powerful to see that, in fact, I've run it with not fully describing how quicksort works on a bigger list than one element. Okay, I had well, that's in runtime. Yeah, you see, now the thing is, what can I do with that? Finally, I would have to like say what to do with a quicksort of the list that is not that trivial. Okay. So you see how dirty the Haskell is? Okay, so it forces me to do some dirty work because I'm not that good at algorithm. I was doing Java EE for like 15 years, and something like quicksort like scares me to death. I wouldn't be able to write it if I haven't like recalled this algorithm. So, but nice thing in Haskell is that we can define the patterns. And what does it mean? I do it for list that's composed of some head. Head is a one element, and tail is another. By the way, one thing you might notice, this quicksort works on anything that can be an integer, string, or whatever. It's never defined. It actually works on whatever. That's extremely generic method. Okay, but let me write it. So what would that be? Quicksort from head and tail. It's in fact, I recently read on the Wikipedia, it's quicksort from some smaller elements, smaller, and maybe I will put it differently. It's just a moment to make it visible. It's actually very important how I write it. And then I have element that's in the middle, but I have to put it in the list. So I'm putting the head, and now quicksort of everything that's bigger. Okay. The thing is, I have to define what's smaller, what's bigger, and that's exactly, it's like natural. Now tell me what's smaller, what's bigger, and in Haskell we do it saying where, like mathematically, where smaller are all those elements. This is a table of all those elements. Let's call them E, like element EL. Okay, that's of course that I take from the tail of the list, tail, which, however, are smaller than a given head. This is like very obvious. So, and a bigger. Okay, I will use copy paste, the most productive technique that it works still in Haskell. So bigger are those elements from tail that are bigger than head. Okay, this is my quicksort, and maybe I have it's like a lot of, oh sorry, just have to compile it. We are linking it, and now we are waiting. This is most of this waiting is because we have to link with a full jar that contains all of Haskell runtime converted to the bytecode, and you see it worked. That was actually the first time it worked correctly, but okay, I'm very lucky on the demonstrations. So okay, you see Haskell works, and we can do the quicksort. Maybe some of you know that that's not the proper quicksort. Who knows what's wrong with this quicksort? Okay. There is one like trick, like one problem, but I'm not going to cover it. But for those from you that know this, there probably I have even somewhere the proper definition of the quicksort in Haskell, and that's not this. Maybe that's this. Oh, that is exactly the proper definition of a Haskell of quicksort done in Haskell, which even works. But I'm not going to cover this today. Okay. However, it's still possible to do the perfect quicksort in Haskell. Okay, so let's go back to the presentation. It's like summarizing what we did. We write some code, then we compile it with Eta command, then we run it as a Java jar, perfectly working. Cool. The thing is that in a Haskell world, as we in Java never use basically Java C, and only if you are learning Java, maybe you use it. That's the same for Haskell. They have something like a build engine, which is, okay, you can look at it as a Gradle for Haskell, or it's more similar to Gradle. And it's called Cabal. This is a standard for Glasgow Haskell compiler tool to build Haskell projects. And in Eta, they have something called itlas, which is basically clone of Cabal that builds projects in Haskell and compiles them, builds them to bytecode, to jars. And you typically have like a couple of commands, like init is a start a new project from scratch with creating some basic empty build scripts. There is a behind the build script. I will not waste much time showing you that. And then you have commands like build or run, whatever, depends what you are doing. If you want to know more about this, Etalang, the page, contains something like tour of Eta, where they explain from basic of Haskell to the basic of building all that stuff in a couple of steps. It's not very deep. It's just to get if you completely have no idea about Haskell, you will learn the basics. If you know something and want to see how to do that with Eta, you will exactly see what to do to build some projects. And now, why is Eta special? What's so interesting about Eta? It's because it's not just Haskell. It's precisely it's GHC, so Glasgow Haskell compiler for JVM. What does it mean? They are concentrated on one particular Haskell implementation and try to be as compatible as possible. Why? Because GHC is in practice the most widely used Haskell compiler in the world. So there are different dialects, other tools, other compilers, but they are not that popular. So we'll discuss it later. There are other implementations of Haskell for JVM, but they have the problem not being totally compatible with GHC. So, okay. So how does it work? It's because GHC is a compiler that works in phases, and there are two important phases. One creates some intermediate form, which basically Eta takes and from this intermediate form creates a bytecode, where normal GHC creates native code. So this intermediate form is quite interesting. It's called STG machine. And that's something nice. So like in Java, we have bytecode, which is kind of abstract assembly language that then we can make working everywhere with a JVM. STG is like minimal functional language. You can even write programs in text in STG, which would be not that productive, but it's possible. And STG is like, what's the minimum that we can express ourselves productively in a functional language? And basically what it supports is, for instance, tile call optimizations, which I will cover later. So first step in Haskell compiler in GHC is to compile, or you can even call it transpile. It's basically compilation to STG, which is a text. You can even see it later if you want. And then this STG is transferred to native code or to bytecode in case of Eta. And by the way, name is spinless tagless G machine, which I have no idea what exactly it means, even though I read a little bit. But it's like, it's not easy task to follow this, but simply you can think of STG as being kind of a bytecode or LLVM for Haskell. However, it's text, not a bytes as in case of bytecode. So, and this is really important. This first phase of transpiling, compiling to STG, let's call it compiling properly, is more or less in Eta the same as STG. The differences are because GHC supports imports in C language, which are not supported by Eta, which on the other hand provides imports for Java libraries. Okay, so and the second phase is having this STG. Let's compile it to JVM, to bytecode. That's finally the bytecode from typical GHC Eta project. You see that's fully readable bytecode that all of you know and can quickly analyze. So the thing is that in real life, the Haskell is dirty, because they use a lot of imports of C libraries for I/O, but also sometimes to do small like performance improvements. And real-world Haskell uses, if not directly uses those imports, it uses libraries that have those imports, and that's something that Eta tries to address. So where in original code you have like import from C, you see call unsafe because C is unsafe. That's part of the standard library for GHC on top. So definition of float, more or less the same as you would have in Java lang. And below is how it was changed to the same type, so the same file, float HS for Eta. So you even see that calls are one-to-one from C to Java, but because of the Java packages being so long, they just do not fit to the line, but this is the same. Okay, so Package. That's exactly the thing where all this dirty stuff lies. So it's like we have a Maven search, Maven repositories, and Haskell GHC guys, they have GHC, and they have a package. That's a page which basically gathers documentations and libraries for Haskell. And this is, for this world, de facto standard. Like, if you are doing GHC Haskell, you are probably using like vectors definition, even some text utilities from package. And a lot of libraries there. As you see, it's like, oh, okay, I didn't really did it well, but you see there are a lot of libraries. It's not this scale as Maven repositories are for Java, but for basically everything. Like you see, there is something for blockchain. They already have something for blockchain. They are cool. So everything is there that you would typically need. So only the scale is smaller. Okay, and then what does Eta if we want to use a package which internally has C imports? Because that would be kind of hard. And they did a small trick. They have a small project on GitHub which contains patches. And those patches are very, very straightforward. You basically say which import from package should be changed, and C import should be changed to which import in Java. It's not perfectly scalable. You can imagine that for every package library that is there, you would have to write that patch. But the thing is that, luckily, first of all, there are a couple of libraries that are really important, and for them this was already done. And in fact, most of the libraries do not contain any C calls, so it's only a matter for those that play with I/O or play with some performance optimizations. So it's still ongoing projects. There are more and more patches coming, but already you have, okay, already there is a lot there. And that's last but not least, what is very important. As I said, Haskell is very dirty. So you would see on typically every Haskell project, something like that, Haskell file on the beginning of the file. It means which compiler extension it uses, and they do matter. Mostly, if you don't have one of those enabled extension languages, something will not compile in the project. And that is the, I would say, the most important part even for Eta, because it accepts all of that, being basically derived from the GHC and having the more or less the same code for Haskell to STG compilation. So to summarize it, like Eta is as close as you can be with Haskell on JVM with GHC. And I already checked it. I can't do for you any statistics, but a lot of the crazy stuff, small projects that you will try, already work on Eta. They just do. And so now let's go deeper how it works, because there are some interesting points. TCO. Who knows what does it mean? Okay. Loud. Cool. That was in that particular case, we are thinking about tail call optimization. And that's, what is this? It means we use, in functional languages, we use recursion a lot. And if we do it, it means we are using a stack. And it means that if you do it not really wisely, compilation, you would mostly end with a code that basically generates stack overflow. And JVM and Java, specifically Java, doesn't have anything for TCO. So basically TCO means I have a recursion because at the end of my method, I'd call it again. That's very important at the end of it. And so compiler will change it to the, instead of the recursive call, to the while, to have a loop to just avoid usage of stack. There are thoughts, so for instance, Scala has something for this. There are even discussions if Java will not have, or JVM, something in the future, but it's like, this is the potential future, nothing there. So let's talk about Fibonacci. That's basically, that's even like a year ago, I was at my level of Haskell understanding was mostly this. I could write a Fibonacci, which would basically mean that I would get any job possible in Haskell, because if you know Fibonacci, you will of course get a job. That's how it works on most of the interviews. But this Fibonacci has a problem. It's not very performant, and even in a very smart languages, it can't be really optimized because it has two recursive calls. So, however, it can be changed. This doesn't look that easy, but it is like Fibonacci that uses tail call recursion, because first of all, that's my Fibonacci, where I call some inner function with n, 1 and 0, and basically it's like this inner function calls itself, decrementing the n, which is basically index in a loop, and then adding sum and press sum. It's basically a very straightforward way of doing the Fibonacci that potentially can be optimized, and GHC Haskell does it. In Java, you would write it this way. However, yeah, this won't help you, because this, even though it is tail call recursion, it's not really supported by the compiler. So you might ask, how many loops can I do with Java? Who knows that? Who guesses? Give me a number. No, of course it depends, because the stack size. But with a typical standard stack sizes you have for Java 8 on a Linux, you would get something like 10,000. And you can make it bigger, but of course, always there will be some end. So there will be some limit. If we do it with Eta, the first thing that happened to me trying that was the result. And in this moment, I realized I've written probably the worst Fibonacci implementation that ever existed. You see, whoever knows Fibonacci knows that that's not really even close. Kind of like, so what was the problem? So at the level I was like a couple of months ago even, my first impression was, I am wrong, because I don't know really Haskell. However, that's like, this is a really easy thing, should work. So I spent even like an hour or more trying to find a bug until I tried it with GHC and realized it gives the correct results on the GHC. So then I realized there is a bug in Eta that I published. And the funny thing then happened, because the developer of Eta, there is main developer, he basically encouraged me to fix it on my own, which was for me very strange. You will see the discussion, because I was able to even analyze where the bug is in the bytecode at the end. This is the compiled bytecode, but it was kind of easy for me being a Java developer for many years. I can read bytecode quickly, but still I couldn't really even think about fixing a Haskell compiler, which by the way is written in Haskell. And it is like 900, I think it's 900 files, so in Haskell. And I am on the level of writing Fibonacci. So, and by the way, I won't go to the details, but basically it was like simple. The Haskell, this Eta compiler at this moment wasn't analyzing the dependencies between variables while doing this optimization. So, because there was kind of typical thing that you would do if you do, for instance, swapping or whatever, which means that finally you are just replacing one value with another. So fixing that. So the developer of Eta encouraged me to learn Haskell and to fix that. And that was awesome. Like I didn't even believe I could do that. But for instance, I've seen in one moment something called CodeGen monad, because of course Haskell is all about monads. And I even knew what is this. I am using them even in Scala, but Haskell is a completely different story. And finally, this is like the first patch I published, which even worked to some extent. It caused other bug, but let's be positive about it. And thing is that I learned the Haskell, and I had a lot of fun. Of course, I wouldn't be able to do that without the help of the main Eta developer and a little bit of community. And it's like, wow, that's awesome. That was even published. Now is a part of Eta compiler. Oh, however, after patching some other bugs that I introduced with this, but it works. So after that, it works, and it's like millions of iterations work. Still, there is a limit There are, because of some internal things, still there are limits, but million of iterations work, so like 100 times more than by default in Java, and you can even make it better. And the thing is, like, there is another technique that's very cool for Haskell. It's called trampoline, and Eta also supports it. So it means that you can rewrite the original Haskell not using the tail call optimization, because you even see that this is the Fibonacci now has 2 calls, and is as it in bad version. But this is basically the same original code, but written with something like called continuation monad. Monads are cool, and there is a special way of calling that trampoline, which basically runs it in a while loop internally and calls those code. And finally, it's again the same result. We can have an incredible amount of recursive iteration without really having the recursion. By the way, this would also work with Java, but we can't write monads in a so funny way in Java as in Haskell. That's the thing, because you basically change a straightforward code and you do very small changes. It's now monadic code that is more powerful. But I will not cover this because it's like, even for me, it's something new. So I'm still new to that. I tried to do so basically it proves that the basic thing of doing the compiler function for a functional language, so tail optimization is done. However, how it basically performs. So I did some benchmark with GMH. They are not very professional because it's like nothing. We are still discussing about not really finished project, and so it didn't even make sense to do professional benchmark. Let's wait for the productive ready version, but something that will give you a number. So I compared the very naive quicksort with Eta, having done the same thing with Java. However, I didn't use a list from Java util, because list in Java util is broken in my eyes. Why is list in Java util broken? Who knows it? Who knows why Java util is broken, and the list especially? Because it's mutable, it's horrible, it mutates. So I'm using Wavre. That's a nice library with immutable data structures, and for me then it's okay, because I can basically have the same code as I would have in Haskell, only written a little bit longer. This is the naive version. Now let's talk about full-blown quicksort. This is the Eta version of a really well-done quicksort. You see it's longer. And this is what I call quicksort in Java. Let's pretend this sort in Wave is quicksort. In fact, it's not. It's merge sort, but I didn't want it to really play with that. Let's compare what is like kind of the best sort we can achieve in Java with the best sort we can achieve in Haskell, more or less, and in Eta. So those are the results. In case of naive algorithm, it was like Java was, this is operations per second, so bigger, higher is better. Java was almost 3 times faster. In terms of the, let's say, more realistic quicksort, better written, Java was like 40%, 30% faster. So it's like, for me, it means, this, especially the second result, it's like this language is already usable. Of course, you will have something in Java faster, but being like 30% slower mostly does not kill you as a business, does not mean you can't use it in a business. Typically, if a language is 10 times slower, that's something you have to consider, or maybe 5 times. But if something is like 2 times slower, it's still possibly usable in a real applications, because in a real application we fight with I/O, mostly not with really performance of CPU that much. Depends, of course, on the application. There's other nice performance check. I also did very unprofessionally, but let's see it. By the way, this GMH benchmark I published on my GitHub. You can recheck on your own anytime, fix something, whatever, because please try for yourself. 12 queens is some kind of a, this was in fact posted on Eta issues list, that this code works really well in GHC, but really, and even quite nice in Frege, which is alternative Haskell implementation for JVM, but really bad for Eta. And I spent a little bit of time analyzing why. I didn't fix anything here, but the developers of Eta, they found out what to do. And initially it was really, really wrong for Eta here, and you see now the comparison at the end, like GHC is like 10 seconds, Eta is 26 seconds, and Frege is now slower. I don't know why. Please don't take it very seriously. That was probably the worst benchmark I've done in my last 10 years, because it even doesn't take into account that the JVM is starting. So it's basically measuring the start of a JVM and initial interpreted code. It's really, really bad benchmark, but it was only to check basically even how Eta and Frege are matching each other. So it means that Eta is kind of okay. I would only say that. So yeah, please remember that. Maybe one day we can do it professionally when Eta is finally published. So Java interoperability, that's something interesting. So you are on JVM, you can now mix it with Java. So that is how to import existing Java type into Haskell, being able to play it. This is the foreign import, how to, for instance, how to import the method. And this is even more like, basically you call Java code as a monad. What does it mean? Because Java is imperative language, so it matters what is first, what is later. And all of that in Haskell should be done in monad. And basically it's like funny, in Eta, Java is a monad. And if you write something in Eta, you can not only take code from Java and call it, you can also export your functions to be used in Java. And there are different styles how can you work with Java together on the same JVM. So there is like, I would say the standard way for Eta, this is really for deep Haskell freaks that spend their life with Haskell. For instance, it's something called WAI servlet, which means let's take your Haskell code and deploy it as a war even, and as a servlet, and run it on Tomcat or whatever. And basically there is almost no cooperation with Java. You just have your Haskell and you can run it even on a WebSphere if you are that crazy. But I'm not covering this topic. I was more interested how can I do something where those worlds really cross each other. So one example is I had a project which is basically Pong. I don't have time to show you that, but this is my typical check of every language. I write a Pong implementation, really classical. And I had this project in Java, so I basically decided, let's change something. I have objects in Java. Now instead of manipulating, for instance, where the ball moves, I will do this manipulation in Haskell. So having Java classes and Haskell logic. That was the idea. And okay, this is the Pong. I don't have time to present you. The demo is on my GitHub. But basically, this is like code in Java, for instance, for JSON serializing. All that thing works. And I can use that code in Haskell, importing all of that, which is like a lot of work. Luckily, now there is a tool that creates for you those imports. It's not really mature, but it's there. And the funny thing, like, that's what I observed. I changed the language and I became a different developer because I've seen new opportunities. So it's like the language really decides how are you thinking. How, really? So I had these lines of code in Java, and for ages I had this, like, a piece of smart code should reduce both methods that we see here into one. I should unify them because those two methods that I have look very, very similar, but for really like years I couldn't find out how to make them one. So I only was changing like what libraries I use, but never was smart enough to find a solution to this copy-paste. In the moment I rewritten it to Haskell, I found out that's perfect place for something called lenses. I will not cover you what lenses are, but this is like a thing you learn while doing Haskell, and you never know, you have no idea where to use it unless you really start writing with Haskell. Then you see exactly that's the place. This is, and even more. Now I know how to fix that in Java. I could use something similar to lenses that would work in Java, but only after having this experience with Haskell I see it. However, it's even my Haskell code could be described as Java because I even use names, like full-blown names packages that I copy from Java, and that's probably every converter from Java to Haskell does Java. So yeah, you see my Haskell code in really smells. And there is another way. So maybe let's do everything in Haskell and use Java only as a kind of controller for that. I have small demo. And that would be this. I'm not going to present a lot of code, but just see game of life. This is classical game of life. I don't know if you can read the code. It's like, I'll make it a little bit bigger. This is like, okay, this is the, you see the, for instance, color, cell, row, a plane, everything that is the common game of life I've defined in Haskell. Is it readable? Okay, this is this. So everything is in Haskell. Only one thing that I will be doing in Java is to call a method that basically takes a whole plane and creates a new version of it. So there is somewhere the method that basically does the step. If we have game of life, you will see that. Just a moment, let me show you that. It's JavaFX code that runs Haskell internally. Let's give it a moment. This is like a first state of a game of life, and I can press next and see the next stages in game. This is really typically looking very cool. So it's like multicolor game of life, and it's nice to place. And this is like almost fully written in Haskell. Only those buttons and the calls of the function that are exposed is done with Java. And this works. So thanks to something called pointer ref, so basically referring to Haskell objects from Java, which are basically even integers like pointer, and we know nothing more about them. So this works. So we have like 3 ways of working with Java. One is totally ignoring Java, just publish a servlet kind of in Haskell. One is really deep, having objects in Java and playing with them with Haskell. And one is kind of in a medium. Let's have objects in Haskell, but give the way of controlling them like controller in Java. So this is this. Problems for a moment, you have a lot of imports, doesn't look really nice. I had other bugs that I had resolved in Eta compiler while doing that. So now, for a couple of years, there exists other compiler, which basically compiles to bytecode, Haskell compiler called Frege. And at the moment, I would say there's nothing wrong with Frege. This is a cool Haskell implementation, proper implementation of Haskell, really, because some people think it's like not the real one. It's lazy, it has everything that's needed, but simply it's done to be Java and bytecode friendly, and it's not really in the mindset that it should support existing code written for GHC. So if you do something from scratch in Frege, you will be very satisfied while learning Haskell. It would work, but if you have existing Haskell code, it will basically probably not work with Frege. It is like 100%, it will not work. So because it can't even use any of popular libraries, etc. So finally, I'm going to the end of this presentation. Is Eta for you? Why would you care? Especially being Java developers and GeeCON. Why would you care about Eta? So what's the Eta now? It's like, this is now they have a little bit, they went one step farther with version, but it's still 0.7.2 in fact right now. I don't know why I have old version of this slide. So if you are thinking about using it for production, there are really people, I meet those people that are having big Haskell code and want to, for instance, at the moment they are forced to rewrite it in Scala. One day it will be possible to do it without rewriting, just running it with Eta. When? Consult typelet. I can't tell you any dates, and I am not, I haven't heard when it will be productive ready. If you are a Haskell developer and you still play a lot with JVM, and that's really a place where you will have a lot of fun because you can reuse your code and try how it runs on bytecode. You might be able to help Eta community. And if you are just Java developer, as I was, for instance, a year ago, it's a nice place to play. Really, I've learned Haskell this way, and I was able to even give some help to the community. So talking about community of Eta, as in every functional language, it's relatively small. So as if Haskell wasn't very small. This is Haskell for JVM, but it's great. The really main developer of Eta is not really concentrating that much of doing this fun job of writing compiler. He's concentrating he's helping people to be Haskell developer and to be productive and to have fun. That's really nice. And he's slowly building a community. I think he does this job very well. And thing is, even being like me, really wrong Haskell developer, really bad one, you could do something for Eta that is fun, it will be fun for you, and even quite okay for Eta, and maybe later you will introduce some bug, but it will be fixed, so no worry about it. So that's my message for you. This really can change the way you write even Java program, and it really, if you want to see the full functional programming, how it works, Eta is one of the ways that still will be close to you if you are a Java developer, because it's still the same machine, and you can mix it, for instance, with JavaFX or with servlets, whatever. And if it's be more popular in the future, that's your job. You can do that. You can change the future. It's fun. Okay, thank you very much. That's all. Follow me on Twitter. Probably you've seen at the beginning my Twitter handle. It was somewhere here. And if you have any question, I can answer them. Yeah.
Once again, so if I understand correctly, the package libraries have to be as some sort of converted,
patched. The package libraries have to be patched in the places where they have C imports.
What is the coverage right now?
I can't tell you, but you can see it's not that many libraries are covered, but it also most of them do not need this coverage, these patches, because basically only those that play with I/O and native stuff. It's like a huge amount, but still not everything.
I see. And the second question, does it means that all the problems of package, like missing imports and dependencies, that's very common from what I've seen, is also there, right?
I'm not aware of that because I haven't encountered this problem. Okay, with versions sometimes, but I'm not a professional Haskell developer to even see those problems. So I've seen only some with versions that I had to change to different version.
Are there some test frameworks for Haskell code in JVM?
Okay, that's a good thing. There is, basically it works, test framework which I forgot the name. Maybe you can tell me. There is a standard test framework which I haven't used, but I didn't use test for Haskell. Quick test or something like this. I forgot it. Quick test. And basically I had problem running it before doing this presentation, and someone from community was helping in that. Now probably it works. I just haven't enough time to check it.
What resources do you recommend for learning Haskell?
Okay, so basically Eta tour if you are beginning, but it's just for Eta, and Haskell itself, they have like very good documentation how to write it. Learn Haskell for greater good or something like that. You will like learn Haskell for greater good. That's it, and you have it, and it works basically. Or read online, yeah, so for free. And there are more resources. I even took part in some online course that was available. But this is like standard resource. Everybody talks about it. I didn't really read everything here, so it still works for me. Okay? So thank you. And yeah, Eta, it's going to be great one day.